Okay, my name is Mike Wigginton. I'm a soil scientist. I live in Marion County and here in Clinton County today to do a local soil judging contest. And this is our first site, Site 1. It's an agriculture site. It's calcareous below 21 inches. Should judge the parent material from 24 to 36 inches. It's not a flat landform and there's not any weak soil development. The P value is 125 parts per million and K value is 75 parts per million with a pH of 7.4. Okay, now for our soil properties. On this one, it said 24 to 36 inches to judge the parent material, and it's pretty clearly dense glacial till. We said on the site card calcareous below 21 inches. There's what we would call a BC horizon that from 21 in between the subsoil and the dense till, and that's where the carbonates come in. But it's definitely dense glacial till in this bottom layer. You can see right by the yardstick here, this is pretty common as far as the seam, the gray seam that goes down through the parent material. Every so often you can have those cracks like that. If you find any roots in the parent material in the glacial till, that's where you're likely to find the roots. Okay, on this one, it's going to be in the neighborhood of 8% slope, so it's 8 to 12% slope. That's going to make it an upland hill slope. Surface color on this one is going to be a brown. I believe it's a Tenwire 4-3. On this one, I called it severe erosion. There's, at the maximum, I can see 4 inches of topsoil, but there's probably even some brown mixing into that. So I think on this one, a good call is a severe erosion. And it's somewhat marginal, but in the top, I was finding clay loam. So it would fit with the severe eroded to have this a clay loam in the surface, moderately clay. In the subsoil texture, you go down into the subsoil right in this area, 8 to 12 inches, and that's where you're probably going to have your highest clay concentration. It's going to be clay loam, and so that'll make the subsoil moderately clay. On this one, by the rules, it said if there are grays within 30 inches, then it should be considered moderately well drained. On this one, there are grays in the dense glacial till, and so as soil scientists, we would consider this moderately well drained, and we would not necessarily consider these as wetness features, but there are grays within the 30 inches that occur in the dense till, and so by your criteria, you're going to need to have a wetness feature there, and it's going to be moderately well drained. On this one, as far as limiting layer, dense till is pretty clear in this site, and it's, since I said it was 21 inches to calcareous material, you're going to have 21 to 40 inches for a limiting layer. As far as the right side of the card, on restore original vegetation, it's going to be mesic forest. Prime farmland, no on this one. High for erosion by water is yes. Wind or high for soil compaction are both no. Grass waterways is yes. Windbreaks, no. Filter strips is yes. Most significant benefit for cover crops on this one, it would be keeping the soil covered, so erosion control. Timber stand improvement, permanent pasture, and crop rotation are all yes. Tillage practices, no-till and moldboard chisel plowing is no on both of those. Water management, drainage, irrigation, and terraces are all no. The N nitrogen value is going to be medium. P is going to be deplete. K is going to be add, and you won't need any lime on this one, none. Nitrogen pollution potential is going to be medium, and the phosphorus pollution potential will also be medium. Of the 4 sites, this is the most straightforward one that we're looking at. It's a typical, pretty typical, severely eroded, moderately deep to dense till soil on a sea slope. So not too much question as to how this one should pan out. Okay? Okay, we're working on site number 2 for the local soil judging contest. This is an ag site. On this one, calcareous below 40 inches. Judge the parent material from 0 to 20 inches. Is it a flat landform? We said no. Is there weak soil development? We said yes. The P value is 50 parts per million, K is 125, and we said this is a 6.4 on the pH. We also put on the notes gray color at 28 inches, and I'll describe that a little bit here in a minute. Okay, going through the soil properties. On this one, we said judge parent material from 0 to 20. And as it turns out, probably 0 to 23 inches is this lighter colored material than what's underneath. And this is going to be local overwash that's washed off of the surrounding areas around here. And so that's probably about 23 inches thick. So the parent material on this site is going to be local overwash. Slope-wise, we're pretty level here. 0 to 2%. So that's going to have it be a field depression. On this one, the colors on the surface, when you wet them up and rub them, they're about they're 4-3, so it's brown on the surface. Since all the deposition is coming into this site, there's none to slight on the erosion. On this one, it's probably loam or silt loam in the surface. I think it was silt loam, so we're going to have a medium surface texture. In the subsoil, I couldn't find any clay textures in the entire subsoil, so on this one we're going to have medium for the subsoil texture as well. I thought around the neighborhood of 28 to 30 inches. There were some grays coming in. Certainly you can see the reddish iron concentrations down there. So that's why I said that there's gray colors at 28 inches, which would lead you to call this moderately well drained soil. On this one, it's actually, if you dug in the bottom of the pit, you would likely find sand and gravel, but it doesn't come in within 40 inches. So on this one, there would be no limiting layer within 40 inches. As far as the right side of the card, restore original vegetation to mesic forest. It's just for prime farmland. Erosion and compaction potentials, all three of those. Water, wind, and high for soil compaction, those are all no. Grass waterways and windbreaks are no. Filter strips are yes. And the most benefit for cover crops are scavenging. Timber stand improvement, permanent pasture, and crop rotation are all yes. No-till is yes. Moldboard plow or chisel plow is no. Water management, all three of those, drainage, irrigation, and terraces are all no. Plant nutrient application, for N it's medium, for P it's none, for K it's none, and you'd want to add lime with the pH we had indicated. Nutrient pollution potential is medium at this site, and the phosphorus pollution potential is low. Okay, that should be it for this site. Okay, we're doing a local soil judging contest today, and we're looking at site number 3. I have the site card right here. They're saying it's calcareous below 38 inches. We should judge the parent material basically from the bottom of the hole from 38 to 40 inches. It's not a flat landform and there's no weak soil development. P is 50 parts per million, K is 50 parts per million, and pH is 5.5. They're not using a disposal, 1,000 tank capacity, and 2 residents in the house for your answers. If we go through the process on this one, this will probably be somewhat confusing to you, but if you look in nearly the bottom of the pit, below 38 inches, and I put it's calcareous below 38 inches, 38 to 40 inches at least is dense till. So based on where we put the judging parent material, you should come up with till for a parent material. On this one, it is fairly level, but this is up on the side of a slope slightly. So we put it about 3% slope and called this 3 to 6%. It ends up being an upland swell based on that. In the surface, I came up with a Tenmar 3.3 surface color, which is going to make this a black for the surface color. Erosion seems to be none to slight on this site. Surface texture is medium. It's probably silt loam in the surface. As far as subsoil texture, I came up with a moderately clay. If you look down around 33-inch zone, we actually get some sandy clay loam in that area, and that's going to turn it into a moderately clay subsoil. Natural soil drainage, I had in my notes here that at 23 inches we start getting a few grays, so that's going to put it into a moderately well-drained soil. In this one, limiting layer, we said that there's glacial till, calcareous glacial till at 38 inches. So that would put it into a dense till within 20 to 40 inches. As far as the right side of the card, is this soil suitable for a home site? Would be yes. Preserve trees, plant new ones, yes. Maintain soil cover during construction, yes. The next four: improve surface drainage, the soil suitable for a basement, designed for high clay subsoils and potential construction hazards on slopes are all no. Install diversion structures and drains is yes. Provide foundation drainage, yes. And high risk for cave-in during construction is no. Landscape and lawn, no application for acid-loving shrubs. Apply lime for lawns. Apply phosphorus. Do not apply phosphorus, and apply potassium. Is the soil suitable for an absorption field? Yes. Based on the formula, we should be greater than or equal to 5 years on the calculation for the cleaning the filter. No, let's see. Filter cleaning interval, I didn't even say that one. I'll put that on the site card. 31D for the pumping interval is equal to or greater than 5 years. As far as the soil absorption field practices, subsurface trench, gravity flow, flood dose, and pressure distribution is no. And the other four: elevated sand mound with subsurface drain and secondary treatment are all yes. On this site, as we'll find, we go to site number 2, we're going to find a lot of similarities. And this, in fact, might be, again, a buried horizon here, an old topsoil in this zone at right about 20 inches, probably. That's a high likelihood, but I put on this one that it did not have weak soil development. And we've said to judge the parent material in the till zone. So I think it's accurate for the properties based on your soil judging, but that's the reason for discrepancy as far as what this looks like as compared to what number 2 looks like. And that should be it for this. Okay, we're here today for a local soil judging contest. This is pit number 4, and we're going to run through the properties to see what we have. On this one, the site card, this is the site card, site number 4. It's a home site. We said it was calcareous below 40 inches. And judge the parent material from 24 to 34. Obviously not a flat landform, and there's no weak soil development. And also the P value is 20 parts per million, K value is 100, and the pH is 7.2. And we also, for the septic tank situation, we said yes for a disposer, 1,500 gallon tank capacity, and 5 residents in the home. Okay, so 24 to 34 to judge the parent material. That's in the material down in this area. And basically, if you go through all the properties, the only thing you would have left in this area would be glacial till. There's a few pebbles in there. There's soil development, clay pickup, just an obvious spot for that to be. Slopes on this one, what we consider a C slope, 7 to 12% slope on this site. With that being considered, this is going to be an upland hill slope. Color on this one is going to be brown on the surface. Erosion is probably going to be moderate. There's some mixing of subsoil, but it's probably moderately eroded and not severe at this site. Surface texture is medium. It's a silt, likely a silt loam here. If you go down in the subsoil in that 24 to 34 inch layer, you're going to have some clay loam, moderately clay textures down there. On this site, within 40 inches, we don't see any signs of wetness, no gray colors, so we're going to call this one a well-drained soil. Also, to the bottom of the pit, we found no limiting layer. There's no dense glacial till. There's no outwash or anything like that. I said on this one that it's calcareous below 40 inches. For the purposes of the contest, that is accurate. But to clarify, just if anyone was wondering, this quite possibly, the top 12 inches on this site look like they've been added in maybe by fill or whatever. And the way I could tell that is this zone from, say, 4 inches to 12 inches is all calcareous material. So this upper part has actually been filled in. So that's why that you have these lighter colored materials over a darker soil down here. This, we'll probably see more of this, but this would actually be considered a buried surface horizon right here. But for the purposes of the contest, that didn't really fall into play. But just so you have a better idea of what you're looking at, that's what you have on this pit. I ran through the other side of the card for what that's worth. Going through 15, is the soil suitable for a home site? Yes, it is. You always preserve trees and plant new ones. Maintain soil cover during construction? Yes, for slope. Improve soil drainage? No, because it's a well-drained soil. Is the soil suitable for a basement? Yes, on this one. Designed for high clay subsoils? We didn't have any, so no. Potential construction hazard on slopes? No, it's not that steep. Install diversion structures and drains? No on this one. Provide foundation drainage? For whatever reason, I put yes. We can double check that. High risk for cave-in during construction, there's no on that. That's going to be sandier textures. On this one, based on the pH, we're going to apply soft sulfur and manage soil for lawns, no application. With the numbers, we're going to apply phosphorus and not apply potassium. Yes, it's suitable for an absorption field. Since there's 5 residents in the house, the cleaning intervals for the septic tank is going to be 6 months. And based on the formula, you're going to have 1 to 2 years for the cleaning out, pumping the septic tank. On the last one, subsurface trench, gravity flow system is no. Flood dose system is yes. Subsurface trench is going to be no. Elevated sand mound system is no. Elevated sand mound and surface drains, no. Drip distribution and secondary treatment, no. And secondary treatment is yes. And that's it for site number 4.
Good afternoon. This is Leah Harden from the Clinton County Soil and Water Conservation District, out on this beautiful September afternoon at our mock soils judging contest. We'd like to say a few thanks before we end the day, and those thanks would go out to, first of all, Ty Brown, who has agreed to allow us to host this contest on his property. So a great big shout out to Ty, and also for excavation of the holes. We definitely want to thank Mike Wigington, soil scientist, for agreeing to volunteer his services, for being the official for the contest today. We also want to thank our Purdue Extension staff. They've used their equipment to allow us to video record this and make it available to you, so that we can accommodate continued learning in a different environment. We also want to make sure that we thank our USDA Natural Resources Conservation Service partners, and we want to thank our Carroll County Soil and Water Conservation District partner, who partner each year with us to host this contest. And most of all, we want to thank the coaches and the advisors for taking the time and the effort to bring the students out and allow them to experience this and to further their soils judging skills. Thank you very much.